Hello, how are you doing today? Welcome. Today we are tackling a super important topic for your chemistry exams, the halogen family, also known as group 17. Now listen, this is a high-yield area, which means the examiners love it. So by the end of this lesson, you will have everything you need to smash any question that comes your way. Okay, let's jump right in. Have a look at the periodic table on your screen. We are zooming in on that column that's highlighted, Group 17. These are our guys, the halogens. Now, for your exams, WAEC, JAMB, NECO, the ones you really need to know are fluorine, chlorine, bromine, and iodine. We're not going to worry too much about astatine down at the bottom. It's radioactive and it hardly ever comes up in the syllabus. So, have you ever wondered where that name halogen even comes from? Well, it's from Greek, and it literally means salt former. And that's exactly what they do. They love to react with metals to create salts, just like the common table salt, sodium chloride, that you have in your kitchen. You need to pay close attention here because this topic is a complete goldmine for marks. It shows up in theory, calculations, and even practicals every single year. So here's our game plan for today. We'll start with what the halogens actually are, then we'll look at the trends down the group, their key reactions, and then my favorite part, we'll break down some real past questions before a final summary. Let's get to it. First up, what exactly makes a halogen a halogen? Let's get into their core properties because once you understand this, all their behavior will make perfect sense. Right, here is the secret to everything about the halogens. It's all about their electrons. Every single halogen has 7 valence electrons. That's 7 electrons in its outermost shell. This means they're just 1 electron away from having a stable, full octet. And this powerful desire to just grab that one last electron is what makes them so incredibly reactive and highly electronegative. Okay, now let's talk about trends as we move down the group from fluorine to iodine. You see, if you can understand these patterns, you can answer so many exam questions without having to cram anything. It's about working smart. This table right here summarizes all the key trends you need to know. Let's quickly walk through it. First, atomic radius. It increases as you go down. Why? Simple. You're adding more shells, so the atom gets bigger. Next, electronegativity. That's the power to attract electrons. This decreases down the group. Fluorine's nucleus has a massive pull on electrons, but as you go down to iodine, there are more shells in the way, shielding that pull. That's why fluorine is the most electronegative element of all. Finally, melting and boiling points. These actually increase. As the molecules get bigger, the weak forces between them, the van der Waals forces, get stronger, so you need more energy to pull them apart. And this leads us to our next point. And this slide shows you that trend perfectly. You can actually see it. At room temperature, fluorine and chlorine are gases. Bromine is a liquid, and iodine is a solid. It's all because those forces between the molecules get stronger as you go down the group. And notice the colors too. They get deeper and darker, from a pale yellow for fluorine all the way to a dark violet for iodine. This is a classic observation question they can ask you in your practicals. All right, time to get into the chemical reactions. Now, this is where the real exam marks are hiding, so focus. We're going to look at reactivity, displacement reactions, and the preparation of chlorine gas. The single most important chemical trend to know is reactivity, and it decreases as you go down the group. Let me be very clear. Fluorine is the most reactive nonmetal on the entire periodic table. It reacts with almost anything. And the reason is simple. It's a small atom, so its nucleus can easily attract that one electron it needs. The order is fluorine, then chlorine, then bromine, and finally iodine. Please, please, please know this order. Now, that reactivity trend leads us directly to a very, very common exam topic, the halogen displacement reaction. The rule is so simple. A more reactive halogen will displace or kick out a less reactive one from its salt solution. Think of it like a stronger person taking a seat from a weaker person. The more reactive halogen just wants that electron more, so it takes it. These are the 3 displacement reactions you absolutely must know. If you bubble chlorine gas through potassium bromide solution, the stronger chlorine kicks out the bromine and the solution turns reddish-brown. Same thing happens with potassium iodide. Chlorine displaces the iodine, and if you add a little starch, you get that famous deep blue-black color which confirms iodine is present. And of course, bromine is strong enough to displace iodine. But, and this is important, it doesn't work the other way around. Iodine is not reactive enough to displace chlorine. So if you try that reaction, absolutely nothing will happen. Okay, let's talk about the lab preparation of chlorine gas. This is a standard practical question. So, you react manganese 4 oxide with concentrated hydrochloric acid. The chlorine gas that comes out is wet, so you need to dry it by passing it through concentrated sulfuric acid. And to collect the gas, we use downward delivery or upward displacement of air. Why? Because chlorine gas is denser than air, so it sinks and fills the gas jar from the bottom up. Remember the reactants, the drying agent, and the collection method. That's what they'll ask you. Now this next part, this is a guaranteed question for your practicals. It's the test for halide ions. First, you acidify your solution with some dilute nitric acid. Then you add silver nitrate solution. The color of the precipitates you get tells you which halide ion is present. A white precipitate means you have chloride ions. A cream-colored one means bromine. And a very distinct yellow precipitate means you have iodide ions. You have to memorize these colors: white, cream, yellow. It's free marks. Awesome, you've got the theory, you understand the concepts. Now let's apply it to some real past questions from WAEC, JAMB, and NECO. This is how you build the confidence you need for the exam day. Let's do this. First up, we have a calculation question from WAEC 2022. The question is asking for the mass of iodine liberated when a specific volume of chlorine gas is passed through excess potassium iodide solution. They have given us the molar mass and the molar volume. Okay, let's solve this together step by step. Step 1, always, is to write a balanced equation. So we have Cl2 plus 2Ki gives 2KCl plus I2. Perfect. Step 2, we find the number of moles of chlorine gas we used. The formula is mole equals volume over molar volume. So that's 0.2 divided by 22.4, which gives us 0.00893 moles. Now for step 3, the mole ratio. This is so important. From our balanced equation, you can see that 1 mole of chlorine produces 1 mole of iodine. It's a 1-to-1 ratio. That means we also produced 0.00893 moles of iodine. Simple. And finally, step 4, we calculate the mass. Mass equals mole times molar mass. That's 0.00893 multiplied by 2554. And our final answer is 2.27 grams. You see, when you follow the steps, these calculations are not so bad. Okay, next up is a JAMB question from 2023. This is a classic trends question. It asks, which of the following properties decreases as you go down the halogen group? Your options are atomic radius, electronegativity, boiling point, and ionization energy. Think back to our trends table. What do you think? The correct answer is B, electronegativity. Remember, we said atomic radius and boiling point both increase as you go down the group. Ionization energy also decreases, and so does electronegativity. It decreases because as the atoms get bigger, The nucleus has a weaker pull on incoming electrons because of all that electron shielding. JAMB loves testing these trends, so please know them well. And finally, a practical style question from NECO 2020. It says, a white precipitate is formed with silver nitrate, and this precipitate is soluble in ammonia solution. Which anion is it? This should be easy for you now. This is straight from our test for halide ions. The answer is, of course, the chloride ion. The first clue is the white precipitate with silver nitrate. That narrows it down. But the confirmation is that it dissolves in ammonia. That combination, white precipitate that is soluble in ammonia, is the specific, definite test for the chloride ion. The other precipitates are not so soluble. This is exactly the kind of question you will see in your practicals.
Fantastic work today. We've covered a lot. Let's just quickly summarize the most important points to lock in those high scores for your exam. This is your high score checklist. If you remember nothing else from this lesson, please remember these 4 things. 1. The order of reactivity is F greater than Cl, greater than Br, greater than I. It decreases down the group. 2. The displacement rule. The stronger one kicks out the weaker one. 3. The silver nitrate test. Colors: white for chloride, cream for bromide, yellow for iodide. And 4. For any calculation, your first step must be a balanced equation. Master these 4 points and you will be able to answer most of the questions they threw at you on this topic. If you found this lesson helpful, please like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB. And subscribe to our YouTube channel right now so you don't miss the next topic. Also visit www.examkp.com for thousands of free practice questions and answers. Let's smash these exams together.